Hello and welcome to Solving Radical Functions Notes. Now before we start solving radical functions, we need to talk about how an exponent that is a rational exponent, so in other words a fraction, can be changed into a root or a radical of some kind. Now what happens is the numerator of your fraction ends up being the exponent and the denominator ends up being the root. So for instance, in example 1 part A, we have x to the 2/3. Well, 2 is our exponent, so we get x squared, and 3 is our denominator, so that's the root. And you can rewrite that. You can either put the square on the x on the inside, or you can square the whole thing, and it'll be the exact same thing. So that's the same as the cube root of x squared. Alright, so no matter how you look at it, they're the same. So let's do that again. 5 is the numerator, so we have y to the 5th power. 4 is my denominator, so that's my root. And again, you can write that as the 4th root of y to the 5th power. One more time. 3 is my numerator, so it's q to the 3rd power. 5 is my denominator, so that's my root, and that's how you rewrite it. Right, and again, you could also do the 5th root of q to the 3rd power. Now you can also go backwards, right? If you have a root, then the root will be your denominator, and your exponent on the inside or the outside, no matter what it is, would be your numerator. So here we would have y to the 2/5. Right? There's no other way to write that. That's just how it is. For B, we have p to the 3/4. So remember, if you didn't need a denominator, you wouldn't. If it wasn't a root, you wouldn't need a denominator. Okay, now look at C. What's the exponent on the inside for C? Well, it's 1. So this would be t to the 1/3 because that's our root. So now that you know how to switch those, we're going to actually use this idea in solving a radical function. So if you look at example, the second example one, we have solving radical functions. First you isolate the radical, raise each side of the equation to the same exponent to eliminate the radical, or the reciprocal of the rational exponent. Solve the resulting equation and check your answers. So first let's isolate our radical. Now our radical here is the 3 to the 4th power. Or I'm sorry, 3/4 power. So we need to get rid of this 2 first. So let's add 2 to both sides. Right, that means we have 3x to the 3/4 equaling 27. Now to get rid of a rational exponent, you multiply or you raise it. Okay, you raise it because remember an exponent to an exponent is multiplying the exponents. But you raise it to its reciprocal. So 3/4 would change to 4/3. And the reason we do that is because if you multiply 3/4 by 4/3, you end up with 1. Right, so that ends up going away. Now what you do to one side, you have to do to the other. So this is also to the 4/3. Well, while I'm here, I'm going to go ahead and use what I just learned. I'm going to change this. So we really have the cube root of 27 raised to the 4th power. Well, the cube root of 27 is 3, and that raised to the 4th power is actually 81. So that's what's going to go down here. And I didn't need a calculator for that, and in fact, you're not going to use a calculator for this when we practice it. Now let's divide by 3, and x would equal 27. Now it's not enough to get your answer. Again, just like anything with roots, you have to check them. So let's go over here and check our answer. When we check our answer, we're taking our number and plugging it in. So we would have 3 times 27 raised to the, all of that raised to the 3/4 minus 2, and we're asking, does that equal 25? Well, 27 times 3 is 81. 81 to the 3/4, that means we're taking the 4th root of 81, which is 3, and raising it to the 3rd power, which is 27. And 27 minus 2 is actually 25. So that works, and that's our answer. Let's do a couple more examples. Now on this one, we have the 4th root. Well, to get rid of a 4th root, you would raise it to the 4th power. So let's go ahead and do that. We've got 4 here and 4 here. Now this one isn't complicated to think about. We get 3x equal to 81, again, divided by 3, and x equals 27. So let's check this. So we have our check. So we're talking about the fourth root of 3 times 27, and we're asking, will that equal negative 3? Well, 3 times 27 is 81, so we're talking about the fourth root of 81, which we saw in the last problem, is 3. But does 3 equal negative 3? No. That means that this is not a valid answer, and our final answer is just no solution. Because we only got one answer, and it didn't work. Now, for some reason, you got 2 answers, and one of them worked, right? That would be the one answer that you would end up with. Let's do the last problem. We have x plus 2 to the 3 over 4 power equaling 8. Well, that means we're going to take this and multiply by its reciprocal. So 4/3. Raise it to the reciprocal. 8 to the 4/3 power is the same as the cube root of 8 to the 4th power. And the cube root of 8 is 2, so 2 to the 4th power is just 16. So that's what we're going to plug in. We get x plus 2 equal to 16, which means x would equal 14 as long as it works. Now we check it. So we check. Let's use some of the space down here. Right, so we have 14 plus 2 raised to the 3 over 4. Does that equal 8? Well, that means we have the fourth root of 16 cubed. We still don't know if that equals 8. Well, the fourth root of 16 is 2. 2 cubed is 2, 4, 8. So that works. And that is our answer. Have a great day.